Good morning. Today we are going to look at our last new lesson of Unit 3. And this lesson is going to be something new. It's not anything you've seen before in a sense, but it's also something that you are going to be using what you've learned up until now with elimination, with substitution, and it just takes time. And that's what makes these problems so tricky is that it takes time and effort and concentration. So we're just going to dive right in. We're going to look at how to solve a system of equations with three variables, with x, y, and z. And so the first thing that we're going to do with these is always to label which equation is which. So I just usually go in order, 1, 2, 3. We want to keep track of what equations we have, which ones we've used, and which ones we're going to use. And so what we're going to do is elimination 2 times. We're going to pick one variable to eliminate twice. So the way that I pick it is I look at the coefficient of my x's. I've got 2, 3, and 1. Of my y's, I've got 1, negative 1, and z has -1, 2, -1. And I'm going to look for which one requires the least amount of work. It doesn't matter which variable I eliminate twice first. What matters is, to me, taking the least amount of steps because I'm a lazy mathematician. So, to me, it looks like the y's are going to be the easiest. I can combine 1 and 2 and eliminate the y's immediately without having to change anything. And then I could also eliminate 1 and 3 and eliminate the y's immediately again without having to change anything. So, if I combine 1 and 3, that's my first pairing. And I'm just going to rewrite this. Oops, sorry, 1 and 2. Doesn't really matter which one I take care of first. And when I combine those, I get 5x. The y's cancel. And then when I add those, I get plus z equals 4. So this is going to be now equation number 4. I'm going to use this one instead. So I'm going to now combine 1 and 3. Because again, I don't have to change anything. I could combine 2 and 3, but I would have to change something. The equations by -1. So and then I'm going to write the third equation. And again, they already cancel out, so I don't have to do anything. I just add straight down. And this is now my fifth equation. Now, this is why we eliminate the same variable 2 times. I eliminated y with 1 and 2. I eliminated y with 1 and 3. And now I have 2 equations that have x and z and nothing else. And so now it just becomes an elimination problem that we can do. So I'm going to combine 4 and 5. Or I'm going to look at what I want to get rid of, I guess is a better way to say it. So looking at this, which variable do you think would be best to eliminate? Personally, I would go with z, because all I have to do is multiply this first equation by +2, and they will cancel out. And I'm going to get 10x plus 2z equals 8. So I did that. And now I'm going to combine them. I get 13x, those cancel, equals 13. Divide both sides by 13, and I get x equals 1. So x equals 1. Okay. Now I can take this value and plug it into what I would put 4 or 5 times value of z. I'm going to substitute it into the equation 5. 3 times 1 minus 2z equals 5. 3 minus 2z equals 5. Subtract 3 to both sides. And I get z equals -1. Now I have two variables, and I can plug these two variables in either equation 1, equation 2, or equation 3, and find the value of y. I'm going to plug them into equation 3 because it's the least amount of work. I would get 1 minus y minus -1 equals 0. So I get y minus 1 plus 1 equals 0. Combining my like terms, minus y equals 0, subtract 2, and divide by -1. And I'm going to get y equals 2. So now I have my three equations, or my three values, excuse me, x, y, and z. Instead of writing our answers in ordered pair, because there are three values, we are going to write our answer as an ordered triple. And you can actually look in your textbook, it talks about how to graph in 3 dimensions. You can skip over that for time's sake, but it explains what an ordered triple is. It's the coordinate of a 3-dimensional point. So that would be our answer. Now, I can go back and check it. It would work for 3 because I just solved it. If I check it with 1, I get 2 times 1 plus y, which is 2, minus -1 equals 5. Let's check and see if that's true. 2 plus 2 plus 1 equals 5. That's true, so it works for the first equation. If I check it for the second equation, I get 3 times 1 minus 2 plus 2 times -1 equals 3 minus 2 minus 2. That would give me 1 minus 2 is -1, so it works. You can also plug this into your calculator like how we looked at before and solve it in your calculator, but this would be the correct answer. Oh, real quick, so that's a lot of work to put into one problem, but it's very doable because it's just using the skills that we've learned till now and kind of just expanding on them and applying them to something that looks a little different. So looking at this one, we notice it looks a little different right away because right here, there's 0, or there's y. There's a y right in there, so it's like having a plus 0y. So I might be looking at my variables and saying, okay, I need to eliminate something twice. I can eliminate x's, all the z's would cancel out. But I already have one equation with no y in it. So what I'm going to do instead, you can do this again a different way if you want. I am going to combine 1 and 2 to eliminate y, because then I already have an equation that doesn't have a y. So in order for the y to eliminate, I would have to multiply the top equation by 3. And this would give me, then for my new number 1 equation, I would get 6x minus 3y plus 3z equals -6. And then I'm going to have the second equation. Now, when I combine these, I get this. This is my number 4 equation. And again, I already have an equation with no y, so it's kind of like a little gift to us. I'm going to combine 3 and 4 together. Which one would you eliminate, x's or z's? X's would be easy enough. I would just have to multiply the second one by -7. But I already have the same number for the z's. They're both 2, so just one of them has to become a negative. So if I multiply this one by -1, I'm going to get -x minus 2z equals +8. So combining those, would give me 6x. My z's would cancel, equals 12. Divide both sides by x. I'm going to get x equals 2. Next step, take that 2. Equals negative 8. I'll subtract 3 from both sides. Oh, sorry, I put 3. 2z equals negative 2. Divide by 2, divide by 2. Z equals negative 5. So now I've got x and z. The last step is I do need to find y. Even though one of the equations didn't have y in it, I still need to find y as well. So I'm going to put this in equation 2. I'm going to get 2 plus 3y minus negative 5 equals 10. So 2 plus 3y plus 5 equals 10. This is going to give me 7 plus 3y equals 10. Subtract 7 from both sides. And then divide by 3. And that will give us y equals 1. Again, we need to write our final answer as an ordered triple. 2, 1, negative 5. If I want to check my work real quick, I'm going to plug it into this equation. It would be 2 times 2 minus 1 plus negative 5 equals negative 2. So this would be 4 minus 4 minus 5. I want to check it out a second. 2 a shortcut there. So that gives me 5 plus 5 is 10. And then the final one is 2 plus and that would give me negative 8. So since it worked for all three of these equations, that means that this solution is correct. And we are done with this problem. So again, a lot of work. So take your time and make sure that you're not making silly mistakes. But it's just practice getting used to seeing how to set these up. If you have any questions, please let me know. I'd be happy to help.